Welcome to another tutorial video regarding AB structures engineering. This time, I will be showing you how to solve for the quantity of cement in bags, sand, and gravel in cubic meters given certain requirements. I will be solving this problem to show you how it is done. A proposed concrete pavement has a general dimension of 10 centimeters thick, 3 meters wide and 5 meters long. Determine the quantity of cement in bags, sand and gravel in cubic meters required using the 40 kilograms cement and Class C mixture. But before that, don't forget to like, subscribe, and click the notification bell to support my channel grow. Before we proceed in our solution, we always have two methods in determining the quantity of cement in bags, sand and gravel in cubic meters. We have the volume method and area method. Any of the methods can be used as long as it is convenient and easier to use. We first begin with our volume method. In volume method, I would like to give an overview on what is concrete proportion. Proportioning concrete mixture is done in two different ways, by weight or by volume method. The most common and convenient way is by the volume method using the empty plastic bag of cement, or by measuring box for sand and gravel. Measuring the aggregates and water by weight is sometimes used in a concrete batching plant for ready-mix concrete or as specified in the plan. In volume method, we always use the table shown in your screen right now, as basis on the quantity of the cement, gravel and sand that we will be solving later on. This table is based on Max Fajardo's book named Estimate. Let us proceed with our solution for me to show you how the table is being used. By volume method, we have to solve for the volume of the given concrete slab. To solve for the volume, we will be using the formula, length times width times the thickness. Substituting values, we have the length of 5 meters, the width of 3 meters and the thickness of 10 centimeters. We have to convert it in meters using the conversion factor. 1 meter is equal to 100 centimeters. We simply solve and we have a volume of 1.5 cubic meters. After identifying the volume, we can now use this to solve for the quantity of the cement, sand and gravel. We simply multiply the volume by the corresponding values from the table 1. This is now the time that we will be using the table of the concrete proportion. In the problem, the required is the Class C mixture and the 40 kg cement. With these, we will be using the values pointed by the red arrows and the encircled values for sand and gravel. We begin with the quantity of cement in bags. We have the volume of 1.5 times the cement value under 40 kilograms, which is 6, and we have 9 bags. Next value. For the sand, we have the volume of 1.5 times the sand value of 0.50. We multiply and we have 0.75 cubic meter for sand. Lastly, for the gravel, we have the volume of 1.5 times the gravel value of 1.0 and we have 1.5 cubic meters. That is now the solution for the volume method. Next, I will be showing you the solution for the area method. Estimating concrete slab by the area method is much easier than the volume method. However, this could be done with the aid of table 2, which readily offer the quantity of cement, sand and gravel per square meter depending upon the required thickness of the slab. To show you how the area method is done, let us proceed to our solution. In area method, we begin solving for the area. To solve for area, we will be using the formulas. Area is equal to length times the width. Substituting values, we have length of 5 meters times the width of 3 meters, giving us an area for our concrete slab of 15 square meters. Now, the next step is to use our table. In area method, we simply use the thickness given, together with the mass of cement and class of mixture given in our problem. Again, our problem states a 10 centimeters thickness, Class C mixture and 40 kilograms cement. With these, you can see in our table that I encircled the values under this requirements. We have the 10 centimeters thickness, cement of 0.600, which is under type C mixture and 40 kilograms. We have 0.0500 for the sand and 0.100 for the gravel. We will all be using these values to solve for the quantity of the cement, sand and gravel necessary for our concrete slab. The next step is to simply multiply the areas by the values we located in Table 2. We begin with the cement. We have the area of 15 multiplied to 0.600 and we have an answer of 9 bags. Next, we have the sand. We have the area of 15 multiplied to 0.0500, giving us an answer of 0.75 cubic meters. Finally, the gravel. We have the area of 15 multiplied to 0.100, and we have an answer of 1.5 cubic meters. If you notice, the values we obtained using this area method is the same as the values we have using the volume method. Thus, any of the two methods can be used depending on what is convenient to you. Also, it depends on the problem that is given. That is now the solution to our problem. Don't forget to like, subscribe and click the notification bell before you exit.